Hello, we're team number 4, and today we're going to present the practice number 3, that it's about hardness test. Hardness test measures the resistance to penetration of the surface of a specific material by a hard object. It is really important because it measures the strength of the specific material. There are 3 really common ways to measure the hardness, that are the ones that we're going to practice today. That is the Rockwell, the Brinell, and the Vickers.
For the hardness test, we need to apply several conditions, in which one is that the surface should be flat, smooth, and completely clean, with no oxides or dust. For that, we could have a completely clean impression of our dent. Also, for our safety and the safety of our machine, we need to verify that the thickness should be at least 8 times the depth of our dent. And also, we need to verify that our material is at room temperature, about 23 degrees Celsius.
The first machine we used was the Brinell machine. The load has to be in 3000. Then you spin this and put your piece in here. Then you pull this and wait for 15 seconds. After the 15 seconds, you push this and spin like this, and you take out your piece.
First, we're going to begin by explaining our pieces. These were the pieces given to us. Here are the length and the height of our pieces, and they were both steel. One was 1018 and the other was 1045. What varies between them is the percentage of carbon. This one in theory is harder because it has more carbon in it. And then please forward. And then here is the table that we fulfilled. To understand the table, first we need to understand our formula. Here is the formula for Brinell hardness, which F is the load in kilogram, the capital D is the indentator diameter, and this one is the diameter of impression. So here the only thing we did was to plug in what we got from the practice. Like in the material, we also did 2 tests for each piece, so we can compare them and get an average. For the first piece, the measured diameter that we did with a microscope was 4 millimeters. The hardness test result was 229 when we applied the formula, and the hardness theory result was 228.76. And for the piece 1045, we applied the same concept. We measured the diameter, the hardness test result, and the theory, and then at the end we investigated the hardness investigation result for both of the materials, and they were really different. We don't know why we got so different results, perhaps of the temperature, or perhaps we did something wrong, but this is how we obtained all the results.
The second machine we use is the Rockwell machine. First, you have to check that this one is in the front. Then you put the piece in here and turn around. You have to check like the big needle turn 2 times, and the little one is in the black point. Then you do this and wait until it stops. When it stops, you pull this and it says the force.
In the Rockwell test, we used 150 kilograms of pressure to take this test. The hardness test result was 20 HRC or HRB, it's the same either way. In the second test, we had 18 HRC and the average was 19 HRC. The machine gives us these results. We don't have to use any formula. And then the hardness investigation result, we got 20 HRC.
Also for this test, we use the same pieces as the Grinnell machine. Then comparing these two tables, we can see that the material CEM45 is more hard because it has more carbon, and also
Here in the Vickers machine, first we have to make sure that the piece is well adjusted here, and then we use this lever to zoom in so that we can see better, and we put in 300 kilograms. Then to use this, we spin for the indentation. Then we press the button to make the indentation. After we look in the microscope, we can find these two lines. With these two lines, we can measure the indentation. To move those two lines, we use this lever. Then, after putting those lines in the indentation, we check for the number here, the red numbers. And then we search for that number here, and then we make the test 2 times. We add those 2 results and get the average.
Okay, for the Vickers indentation, we have the manual and the computerized. So, for the manual, we need to do several steps. First, we need to do the dent. After we do the dent, we need to take diagonal 1, which is this side to this side, distance in millimeters, and diagonal 2, which is the distance between the top part to the bottom part. At that point, we get an average, which we have here 4.7.3, and that average we square it. Here we have the formula to have the HB, which is 1.87 force. The force is the applied force in kilograms, and the diagonal and the average diagonal in square. And here we have the hardness. Then, to make sure this is correct, we take measure 2, and we exactly the same steps. We take diagonal 1 and diagonal 2, and then we take an average. The average we put in a square, and we put it into the formula with the applied force in kilograms, which it is 0.300 kilograms. And here, in the computerized mode, as this computer does everything for us, we couldn't even have those data because we already have the results.
We need the metallographic finish because without it, the material will have many undulations and it maybe gave us bad information.
The main use of the hardness test is for us to know the hardness of the material, what we can use it for, and where we can use it. The main recommendations to make the hardness test is to make sure that the equipment is calibrated, that we use the indentations with the correct specifications, and to use the correct security measures.
The Grinnell hardness test is specific for iron and steel, and also for non-ferrous alloys. And for the Rockwell, it is specific for heat-treated iron. Also, the relationship between the Grinnell hardness and the UTS is really simple, because the UTS in PSI is equal to 500 HB. So we got the HB, therefore we can obtain the UTS for the tensile test.
For industrial engineering design, and many careers which involve creating stuff and making things work, we need to do material tests. For that, also we need to have a vital course which is called process of manufacturing. In process of manufacturing, we learn how to create stuff, and one of the main steps for the process of manufacturing is test materials. Test materials is one of the most important steps for a creation, as we need to know how our materials will have effect in one product that we design. For instance, we use beakers and the Brunel, because we needed to know how strong was our metals and how much strength can we put on them.